Okay, afternoon. Today we're going to be looking at functions, which is a new topic. I guess you know bits about it, but you've not explored it in this detail before, potentially. So we're going to begin by looking at function machines. Okay, and then we're going to abstract these ideas, take them to more an abstract way. But you have an understanding of functions from function machines already. So it's going to be new notation. We're going to be looking at that, and also some inverse functions and something called composite functions. And then in possibly another video we'll look at domains of functions and maybe graphical representations, but we might come on to that another time. Okay, so let's take a function machine like this one. So you take x and then you minus 6. So the next thing you would have is x minus 6. And then you square root this. So if you square root x minus 6, you get the square root of x minus 6. Now we might give this function machine a name, and so we might just call it f. So f is this function machine. It takes something, takes an input, it subtracts 6 from that input, and then it square roots that answer. So if we were looking at what would f do to 10, well 10, it would take away 6. Okay. So that would leave you with 4, and then you would square root this, and you would be left with 2. So this f, that's what it does to 10. So maybe you could complete what does it do for a. Maybe pause the video. So a, it subtracts 6, so you get a minus 6, and then you square root that. So when you put a into the function machine, you end up with the square root of a minus 6. What does it do to dog? Pause the video. So it takes dog, it subtracts 6 to give you a dog minus 6, and then square roots that. What does it do to 1? Maybe pause the video and work out what it does to 1. Well, if you subtract 6 from 1, you get minus 5. But you can't square root minus 5. So you can't put 1 into the function because you get something that doesn't work. You can't square root a negative number. So we say that when you put 1 in, you end up with an answer that is undefined. Okay, so let's look at some notation now. So if we were to write this in IGCSE, you might say that f dot dot x goes to the square root of x minus 6. This is very similar to the function machine notation. You might use this notation though, f of x is equal to the square root of x minus 6. These two things mean the same. Okay, so you can see how the black writing there is related to function machines. The name is f. X here is the input. This is what goes into the function, and then the square root of x minus 6 is what comes out. Okay, so this is the notation explained. Right. If we were going to write all of these function machine notations using the second set of notation, so the first line there would be f of x is equal to the square root of x minus 6. F of 10 could be the square root of 10 minus 6, which is the square root of 4, which is 2. So we could just write f of 10 as 2. When you put 10 into the function machine, 2 comes out of it. When you put a into the function machine, you get the square root of a minus 6. When you put dog into the function machine, you get the square root of dog minus 6. And when you put 1 into the function machine, f of 1 is undefined. It doesn't have an answer we can write down. Okay? Right, I'll pause for a second. Okay, I think I'll stop this video here, make it short, and then have another video for inverse functions to follow. Thank you for watching.